You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Amazon Web Services is the world's most comprehensive and broadly adopted cloud platform, offering over 175 fully featured services from data centers globally. Millions of customers trust AWS to power their infrastructure, become more agile, and lower costs.
Hey all, we're here for a little chat around the picnic table at the Open Source Summit North America in Vancouver, British Columbia. I'm here with some developers and engineers from Amazon Web Services who are going to talk to us about Apache Airflow and the service that you offer, managed workflows for Apache Airflow. So joining me are Dennis Ferruzzi. Hi, Dennis.
How you doing?
Niko Oliveria.
Hey, thanks for having us.
And Raphaël Vandon.
Hello.
Excellent. So I want to talk a little bit about what actually is Airflow just to get it started. Maybe, Raphael, you can just give a quick description of it.
Yeah, sure. It's basically a service that lets developer schedule and organize their workflows. It's basically when you have to do a bunch of stuff in order and waiting for the stuff previously to be done before you do the next task and everything. And you want to do it several times during the day or maybe at several days during the month. All of this is organized by Airflow. And Airflow also is connected to many different cloud providers and services to help you do the stuff in a simple way, basically.
Excellent. You know, it was created by Airbnb, as I understand, and it's widely used. I see it used by a number of companies out there, a number of your peers and other providers out there. And the elephant in the room right now is machine learning and AI, right? We're hearing so much about it. And I know there are some applications for Apache Airflow. Is that a primary use case, or is it more just what it can do? Maybe, Niko, you could help me with that.
Sure, yeah. Airflow is such a good generalized platform. You can do just about anything with it, but ML is particularly well suited. You're often building pipelines to manage data, train models, deploy the models, and Airflow is generic enough that you can use it for the whole pipeline. So everything from fetching data, doing ETLs, tagging data, then doing the training, deploying that model, testing it, sending it to prod. So ML is a perfect application because it's very pipeline. You want to keep scheduling and training that model on a regular basis, so that's where the scheduling aspect comes through. So yeah, it's a perfect application. There are many, but ML is a good one.
Or what are some of the kind of contributions that you're seeing upstream that speak to the project and how it's thinking about ML and AI?
One of the things we've been working on is its integration with AWS, with SageMaker specifically.
Okay.
Which goes back to what Niko was just saying, where there are built-in operators which allow you to interact with the various SageMaker endpoints. So you can train the model, so you can upload data to S3, for example, and then have the data pulled from S3 into SageMaker, where it trains the model, and then you can send your fresh data to SageMaker to test against your model to get your predictions. So that's one of the things we've seen used, specifically ML related.
Excellent. So as I understand, Apache Airflow 2.6 is now available. You know, what strikes you about the release, Niko? What is it about the release that strikes you?
So there's some UI improvements in 2.6, so some like user-facing UI features, better filtering, better graph views, some optimizations, tasks will be queued better and transition from queue to running more efficiently. Our team has delivered some optimizations, actually.
Maybe you can talk about it. I'm excited about Airflow 2.6 because I worked on an optimization to make the parsing of the description of the workflow basically go faster. We've seen improvements between 75% and 25% faster. So I'm excited to see this being rolled out to the clients and having them benefit from this optimization.
What did you all do to make it faster?
It's maybe, I don't know if we have time to go into the details, and optimization is always a bit stupid when you explain it afterwards, but there was some investigation that we realized that it's always the same with optimization. It's the same thing that was doing all over and over again, and we found a way to have it done once and not being repeated for every single workflow that you are parsing.
Okay. Great. What strikes you about 2.6, Dennis? Or Niko, anything else that strikes you about 2.6? I mean, what is it that you see kind of in terms of what users are asking for that reflects 2.6?
I think the UI improvements are a big user-facing one. Another thing that we're excited about in 2.6 is Airflow has this conception of executors. So you build workflows, you schedule them to run, and then they execute in different environments. And we've been working on some changes to make it easier to plug in external executors, so customers can build their own and tell Airflow, like, hey, I want you to execute my tasks in this environment with this service. And we've been building some of that stuff, and most of it's launched in 2.6. There's still more to come, but that's pretty exciting too.
I don't know who the best one is to answer this question, but one of the questions I did wonder about is how Airflow captures data and processes activities and coordinates the real-time updates to distributed environments.
Yeah, I can take that one. So Airflow itself tries to be pretty transparent, actually. It's more of like a workflow orchestrator. So people use it all the time for ETLs. Data is huge in Airflow. So like loading data, transforming that data, sending it somewhere else afterwards. But most of those actions are happening outside of Airflow. So you're maybe putting your data in S3 and downloading it from there, and maybe then you're sending it to Spark or Hadoop and doing some transformation on it, and then maybe you're getting that, sending it to some data warehouse. And Airflow is just there to allow you to describe that workflow, schedule it to run whenever you want it to run, and make sure that execution is happening in whichever service you've added to your workflow. So it can be anything under the sun, really. It's super generic.
Dennis?
Yeah, something we say a lot with new users specifically is if Airflow is doing the job, then you're doing it wrong. Airflow is orchestrating and controlling other services doing the job. So if you're doing any kind of heavy workload on the Airflow worker itself, you should probably find a better way.
So Raphael, what are some of the common mistakes you see people use when they start using Airflow that speaks to what Dennis is talking about?
So Airflow is known to be used by people who are not always super familiar with writing code. It's more like a data analyst and people who work with data. So I think there is a lot of mistakes you can make when you start using Airflow. One of the most common ones we can see, and one I've been working on trying to improve when you do the bad stuff, is writing a lot of code in the description of the workflow you want to do. It should be just a description, but people tend to put a lot of logic in there, and that logic has to be run every time we evaluate the workflow, which happens very regularly. So it can put a lot of load on the system. We call it like top-level code, which is a bad thing. This
what
is
kind
like
of code
a
do you
very.
call it?
It's a top-level code. It's basically code that's at the level of the description instead of inside the tasks. It's something that happened very regularly.
It's worth pointing out that the way you describe and build the workflows, we call them DAGs, is in Python code. So it's not something declarative, it's not YAML or config based. So you can do anything under the sun in Python. The DAG descriptions should just be the tasks in the DAG, how they connect to each other, when they should schedule, but people do all sorts of stuff, because you have Python.
This gets to the underlying architecture of Apache Airflow. Can you describe DAGs and what they're based upon and how they kind of fit into the architecture itself?
Yeah. So basically Airflow provides an SDK. There's an Airflow package, and that provides you the building pieces you need to build DAGs. So there's a DAG model, which has schedules, whether you want success or failure callbacks, retries, this type of thing. And then you have this conception of tasks, and each task is an individual piece of work that's done. And one task may link to another, one task may link to a parallel set of tasks. You just connect these building blocks together with what we call operators. And Airflow itself ships with some, which are some generic Bash and Python, so you can have the task just run some code, or you can have the task talk to S3, or you can have the task talk to EMR, start a job, that type of thing. And then that DAG declaration is taken by the Airflow scheduler and run on the execution environment.
So Dennis, what do you see in the DAG architecture that strikes you as compelling? What is it about it that really you find captivating?
Yeah, I really like what Niko kind of hinted at were the operators. They're like those legally distinct generic building blocks, where each operator does one specific task, and you just chain them together in different ways. So for example, there's an operator to write data to S3. And then there's an operator that will send the data to an SQL server or something like that. And it basically, the community develops and contributes these operators so that the users in the end are basically saying, the task I want to do is pull data from here. So I'm going to use that operator. And then I want to send the data to somewhere else. So I'm going to go and look at, say, the Google Cloud operators and find one that fits what I want to do there. And you can it's cross-cloud. You can interact with so many different services and cloud providers, and it's just growing. We are at 2,500 contributors now, I believe. And it's just like people find a need and they contribute it back, and now that blueprint exists for everyone.
Is there a graph database underlying the architecture itself? Did I read that, or am I wrong in that?
There is a database. It's just a relational database. It's nothing too fancy that keeps track of DAGs and schedules and results. So no, nothing too.
So what is this? What is the secret sauce, so to speak? Is it what Dennis is describing here? That
I think if you had to pick a secret sauce, it's maybe the scheduler logic. That is kind of the heart of Airflow itself. Yeah, and then this community of operators. The beautiful thing about Airflow, I think has made it so popular is that it's so easy. For one, it's Python. Python's easy to learn and pick up. And two, we have this operator ecosystem. So companies like AWS and Google and Databricks are all contributing these operators, which really wrap their underlying SDK. So for users, it's easy to build these workflows.
That's the fit, isn't it, Raphael? Those operators. What is it that you want to see emerge with the operator? With the operator kind of environments that you're seeing, what are kind of the next evolutions of it?
We didn't talk about it before, but in Airflow 2.6, there is the operators, which are an interesting thing. There is also sensors, which are basically operators that just wait for something to happen. And in 2.6, there is notifiers that happen, which are something you do at the end of the workflow. And I think this is like an evolution is mostly like moving out of the operators and giving like more flexibility. Instead of having to put an operator at the end of your workflow and be sure it happens, you can just put a notifier and it's going to act depending on the success or not of your workflow. It's just making things simpler for users. And operators are very versatile. I think they can be used in many different ways, but we can even extend this with like sensors and notifiers and whatever coming next.
So, how does AWS plan to further integrate Airflow? What are the kind of things that you're hearing customers ask for? And I think maybe even also customers, but also people in the open source community.
Yeah, so as mentioned earlier, that our team is dedicated strictly to working on Airflow. We work with community issues and feature requests, but we're adding new operators all the time, which interact with new services. Sorry, Niko, you're going to have to take that one. We were just talking about one yesterday. We were going to add features for a new service.
Yeah, we have EventBridge coming up. We're going to add some more operators for working with MWAA itself, which is the AWS managed service for Airflow. So we work very closely with that team. We help make changes to open source Airflow that makes MWA better for their customers, and since we're making open source changes, it makes Airflow better for everyone else. So Amazon pays us to make Airflow better, and then that makes Airflow better for the whole community.
Yeah, and that's the managed workflows for Apache Airflow that AWS offers. What is differentiated, just in conclusion, with MWAA?
I think, like most managed services, the differentiating factor or the reason you'd pay for it is just ease. Setting up these Airflow environments, you need your scheduler running and workers, and you need a lot of bits and pieces, and they all need to talk to each other. And AWS says, like, hey, let us set all of that up for you. You click a button, we'll set that up, we'll send you the URL, you give us your DAGs, we'll run them, we'll make it super easy. That's the selling point.
Which then says to me really the kind of the need for you as a team to really be very cognizant and aware of the open source community and what's being developed in the community itself, then helping bridge that with the NWAA product. Is that right? Would that be is that a way to characterize it, or am I wrong?
No, I'd say that's right. Like, MWAA tries to be unopinionated about Airflow, so MWAA uses vanilla Airflow. You know, a lot of companies may be teased to modify Airflow to suit the needs of the service. And MWA doesn't do that. If they want Airflow to be improved or changed in a particular way, it's up to us to make open source changes for the community. We give all of that back. So, yeah.
So what's next for Apache Airflow, Dennis? What do you see coming next? What are some of the exciting things you're thinking about that are coming next, post 2.6?
Yeah, I'm working on integrating OpenTelemetry, which is a new, well, it's not new, it will be new to Airflow way of observing and fetching metrics, so you can get much more granular details about how your system's running and things like that. Personally, that's what I'm working on. Let's just go down.
We have another project that one of our team members is working on, multi-tenancy. So Airflow right now, you know, enterprise companies have huge Airflow instances that a lot of teams use, but Airflow itself is not great at multi-tenant. You know, you can see each other's DAGs, the user authentication is kind of shared, the database is kind of shared. So we're working on a bunch of proposals to get Airflow to be fully multi-tenant. So you could have one Airflow deployment with completely isolated teams using it. And this will be a game changer because that'll allow people to completely collapse down the number of environments they're using. So if the sales team needs data that's only in their Airflow and the DevOps team needs their Airflow, eventually we'll be able to combine those all into one instance that's shared but in a secure way.
In a secure way.
So we're building that, and it's going to take a while to ship, but that's going to be a big one. Yeah.
And Raphael, any thoughts?
There's also something that's pretty old to Airflow, which is deferrable operators, which is an operator is running on a worker server, and usually they spend a lot of time waiting for network to come back and for tasks to complete. And with deferrable, you can use the worker to do a bit of the preparation, send the request, and then you defer waiting to the scheduler, so that you don't have to keep the machine active and blocked for this task. This has been a capability of Airflow for a long time, but all the operators need to be converted to this, and we are seeing this progress, especially now, especially in AWS. So I hope that people will be able to use less workers to do the same task in the near future.
Well, thank you all for taking the time to talk today about Apache Airflow. Have a great show at the Open Source Summit.
Cheers. Thanks for having us.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.